We can get started. This is a short talk of 25 minutes. So I'm Bharat and I'm from Microsoft. I basically contribute for the Linux SMB client, and I also work on enhancing the end-to-end performance for the Azure files. And let's talk about SMB protocol. SMB protocol was developed by IBM in 1983, and the latest major version is 3.1.1. And port 445 is used as a common. I mean, by default, we use port 445 as a common default TCP4 for TCP connections. And Linux client is located in the Linux kernel, and source code for that is like under FS-SMB client. There is another folder under SMB which is common, and it is shared between the KSMBD and Linux client. So today I'll be covering the traditional debug methods that we have, and also what Microsoft, my team is looking at to improve the debuggability aspect of the Linux client. So we have a dmessage, which is one of the traditional way of looking at the kernel logs, and cifs is a part of the kernel. So we can look at the dmessage whenever something bad happens with the Linux client. It shows the critical logs in the dmessage. So, but if you want more verbose logs, you have these commands to enable more logs on the cifs client, and at the end of it, you have to echo 7 to the cifs-utils, which basically enables verbose logs. If you want to disable after some time, then you can use echo 0 to cifs-utils, which basically controls the verbosity level. And this is an example of a dmessage while trying to mount a share. If you get a no such file directory, that is because, as dmessage says, you are actually using a wrong network name, because I used a share which doesn't exist on the server. So then once we get this error, we are actually at the client, we are translating that error to Linux error, and that -2, which is no such file directory. Apart from dmessage, sometimes dmessage may not be helpful if there are too many operations going on and it is difficult to filter the dmessage. So we can use the trace command, which is based upon the ftrace. What trace command does is like it allows us to capture the trace commands at the cifs client level. cifs client has more than 100 trace points today, and it also allows us to capture a specific trace point by mentioning with a E option. Once, say, after you collect the logs, you can do a Control-C to stop the capturing. After that, you can do a trace command report, which generates basically it decodes the collected trace points and generates a report. This is an example of that. Say I use the same way, like I mounted a share which doesn't exist. So we are sending from the trace command logs, we are sending command number 3, which is a tree connect command, and we are getting back the error from the server, which is highlighted on the slide, and we are converting that error back to Linux error, and which is -2, and then we are returning the same error back to user space. And sometimes it happens that we won't be able to analyze the issue even with the trace command and dmessage logs. So that's where the TCP dumps are helpful, which helps us to debug some connection issues or problems which are deep inside protocol stack of SMB. So I've shown the command to capture the TCP dump, and if a customer or if a user is using SMB3 version, usually the traffic would be encrypted. So if you want to decrypt and look at the traces in a decrypted format, then we have a helper script in the cifs-utils called SMB-info, and you can pass keys as an argument to that, along with the path to a file share, which actually provides a decryption keys. With that, you can use those keys to enter to a Wireshark, and then you would be able to see the decrypted traces. More information is present in that wiki I've highlighted in the slide. You can take a look at that. This is an example of how Wireshark trace looks like after decryption. And these are the other useful commands that we have that we need during debugging. So first one is uname, which provides a Linux kernel version, and the second one is like module info of cifs, which gives the cifs Linux kernel client cifs version. The third one gives the cifs-utils version, which is a user space helper utility needed to mount a file share with the cifs client. And mount-t cifs gives the list of all the shares mounted with the cifs clients. The last one gives the list of connections, list of TCP connections which are connected from source to destination and are using port 445. Basically, these are the SMB connections. And few in recent kernels, we've also added a mechanism to pass the Linux kernel version and cifs client version to the server. So now if server want to know what is the client version and the server version, they can look at the negotiate context here, and then they will be they will get to know what is the Linux client version that they have based on without even asking customer or Linux client. So next we have the procfs. We have some of the procfs data structures where we populate the more information about the cifs client. The debug data shows the information about the module and cifs version, and also this is basically for the active shares. So it provides the details of the tree connect ID and credits, available credits on that connection, and also the capabilities that server and client has been communicated, and also the status of the current existing SMB session. And it also talks about tells about the mids, which are the current in-flight requests which went from the client to server, but the client is still waiting for the response from the server. Then we have our stats. Stats provide a overview of the mount, how many operations of each type has happened on particular share, and how many of them are failed for different reasons. And it also talks about how much data has been read and how much data has been written. So this provides a very high-level overview of what is happening in the file share, whether there are any reconnects and other stuff. If you want more granular version of the statistics, then you can enable cifs-stats2 compile flag, which provides the details like what is the slowest request and what is the average latency for each request and that stuff. I'll talk about more about this in my next slides, where we use eBPF to do the same. And the next is there is a tool called SMB IOstat. We use a space utility which actually uses this data structure, stats data structure, to populate different information and different statistics. Then I've captured the list of common issues that we face during the mount. If it is a connectivity issue, you check for Wireshark and make sure server is online, and also check if port 445 is unblocked. And if there is a protocol mismatch, you would usually get an error telling that operation not permitted. So then you make sure the server and client actually supports both server and client are compatible with each other with respect to versions. And if there are any permission denied errors, then it could be because of username or password errors. Then you will get no such file directory errors for incorrect share or path name. And for unmount errors, if there are any handles opened on the client, you won't be able to unmount and you would get target busy errors. I won't go in too much inside this, but I've added the references at the end so that you can take a look and let me know if you have any questions. Then other common issue that we have is like leaked handles. If you want to the leaked handles can happen for multiple reasons. One of them would be leak at the application or leak at the client side, or leak at the server side. If there is a leak at the application, then we have a strace tool to check if close call is coming from the application to the kernel. If it does, then we can also check lsoff to check if there are any opal files. If say there is no leak at the application, then the other place to check is if there are any leaks at the cifs Linux client level, and we have a proc-fs file system, file called open files, which tells about the file which are open here, and it also tells about the session ID and process ID which is keeping it open. This is generally useful. Say we have a feature in the Linux client where we defer close. In that case, it stays for some time, but after that, it should go away. If it is not going away, then client is holding some of the handles. If those two cases are not happening, then it would be a leak on the server. As you see, I've explained different ways of capturing debug data at different levels or different structures. So it's very hard to capture all the debug information. So our team is working on a utility called always on diagnostics, which captures all the necessary diagnostics at one and basically keeps at one place so that whenever we want, we can get the data from the customer. It also, along with capturing, it also monitors for errors on the file system, which basically automatically get detected, and once it detects, it captures the necessary information after it has been detected. So this is basically a daemon, runs as a system service, and it can be configured to get different kind of anomalies. It can be from eBPF scripts, or it can be from DMSs or any others. And it also provides the general information about CPU and memory usage of the system. It makes our life easier to get information from the customer for the cases where it is impossible to reproduce issues in-house, so that we can provide this tool to the customer and get them the logs necessary. So how does AOD traces the anomalies? AOD is always on diagnostics. So it uses a eBPF technology to look for anomalies, and we have developed some of the scripts, and thanks to Mitakshi and Karthik, who played a big role in developing these scripts. There are two types of scripts as of today, and we plan to develop more in future. These scripts work at different levels. One, if there are scripts VFS related and SMB slower. In VFS related scripts work at the end of a VFS stack, and basically the call when happens from between the VFS and SMB layer, and the SMB slower or SMB IO snoop works at the end of SMB layer, where we actually transmit the data over the wire from SMB. So as I mentioned, SMB slower tracks all the SMB operations, and it measures the time spent in each of the operation, and it prints all the details, which operation took how much time. It is also configurable, like you can specify the threshold after which you want to trace a specific operation. And VFS is on a similar lines. It does the same thing at the VFS, basically tracks at the different layer that I've shown earlier. For example, this is the use case where if you want to figure out the requests from SMB which are taking longer than 1 millisecond, we can use this script with 1 millisecond as an argument. It provides these details along with the timestamps and the operation and the PID which was doing the operation and how much latency it took. And it also provides additional operations like session ID and whether it's a component request and other stuff. And we have IO snooping operations, which are used to basically trace the written codes at the SMB layer and also at the interface between VFS and SMB layer. At the SMB VFS snoop tracks the callbacks that VFS makes from VFS layer to SMB and provides the return values here. As you see here, for example, for a cifs open, we are getting all the information, example inode and file name, and also PID and the return value, what SMB is returning back to the VFS layer. So why and how this SMB IO snoop and SMB VFS snoop is useful is that, so the always on diagnostics will keep looking for anomalies or the errors which are originating either at the SMB layer or at the VFS layer. Whenever it observes specific error, then we can actually stop all the capturing and get a bunch of files where we can analyze later. And apart from this, we have a cifs subcall program where so cifs subcall is necessary. We have two types of subcalls that we make from the kernel client to the user space to get some information from the user utilities. One is for Kerberos negotiation to get a ticket details for the Kerberos, and other one is to get a DNS resolution during the reconnects. cifs subcall utility helps us to achieve that. The kernel has something called request key utility function where we can call that along with these parameters so that the request will go to the user space utility and help us to get the necessary information. And for that, you need to configure the request key properly so that with a proper argument, so that request key function finds the right description and finds the right binary to call along with the arguments. As I mentioned, we use a cifs.upcall for Kerberos to get a ticket. So to debug any of the Kerberos issues, you should make sure that you have a TGT before you actually mount. Once you mount once you have a TGT, you try to mount a share, then cifs.upcall utility will try to get the service ticket needed by using the TGT. And once you have it, you should be able to mount a share. You can verify if you can mount, if you have the tickets using KList program, and if you have any issues that we face, that you face during the mount, you can look at the system logs and figure out what's going on. I've added more of the references here for you guys to go through, and this contains most of the useful things with all topics that I've talked so far, and helps us to debug. Any questions? Yes, Steve.
So one of the things I was interested in is a lot of the times the debugging stuff that's most useful comes from people who have problems with code. And so one of the things I was trying to see is how, have you thought at all about how we encourage people to contribute additional trace points or additional debugging stuff or additional tools? Or obviously Samba has some useful debugging tools that you know, for example, WinBind has the WLead info utility. We have these things in cifs-utils as well, but I'm kind of wondering how we encourage people to contribute to utilities. How do we encourage people to ask for new trace points? Because realistically, if somebody reports a problem, tomorrow somebody else is going to report the same problem. And so a lot of what we need to do is just be open to keep adding and adding and adding and adding better debugging.
Yeah.
And then making sure people are aware where to look. And I think the Linux troubleshooting is a great example. We ought to probably post some more stuff up there that has
Not yet. I'm yet to have such discussions. We are making those eBPF tools as open source, so anyone want to contribute to them, they can start and extend them if needed.
One of the recent discussions related to this was somebody said, oh, I'd be fascinated to write a tool like a mount discovery helper to like, there's 20 different problems that can occur at mount. And a little user space tool that tests, okay, is the port open, is the firewall blocking it, is my whatever, you know, checking the 15 or 20 different things. And, you know, a lot of times people use SMB client for that today, but we could come up with little mount helpers that debug mount better, because there's so many common things that happen at mount time. So it's fascinating to me. I was interested in writing one of those. I don't know what to call it, but I think this is really good because externally people are aware of this. People have some great ideas about additional tools.
Yeah. Thank you.